This is a linear review for Algebra 2. So in this video, we will be practicing graphing lines with positive and negative slope and horizontal and vertical lines. As a quick review before we get started for the first one, I want to write up the general equation for slope-intercept, y equals mx plus b. M is your slope, so that's your rise over your run. If it's positive, remember, your line is rising as you read left to right. If it's negative, your line is falling as you read left to right. B is your y-intercept. Remember, your y-intercept, your x value will always be 0. So for number 1, the equation is already in y equals mx plus b form. So I have my slope. It is negative. That's telling me my line should be falling. And I have a starting point, my y-intercept. So the ordered pair 0, 4. If an equation is already in y equals mx plus b form, you first plot the y-intercept, 0, 4. You then use that as your starting point and use your slope to get your other points. Since my slope is negative, I'm going to go down 1, 2, 3, run 1. Go down 1, 2, 3, run 1. I can also go up a positive 3, but go over in the negative direction. And then you can connect your points. And we have graphed y equals negative 3x plus 4. Once again, the y-intercept is 0, 4, and the slope was negative 3 over 1. For the second one, you can see that the equation is not in y equals mx plus b. So we're not able to look at this equation and get the slope and the y-intercept. So we need to solve this equation for y first. All right, so I'm going to take and move the x to the other side by doing the inverse operation. Okay, I'm going to bring down a negative 3y. You cannot combine the 6 and negative 2x. They are not like terms. And then the last step is I need to get y by itself, so I'll have to divide everything by negative 3. Be careful with your signs. Negative and a negative, that leaves me with y. Okay. Here I have a negative 2 over negative 3. That is a positive 2/3 x. But a positive 6 over negative 3 is a negative 2. So now my equation is in y equals mx plus b form. My slope is 2/3. My y-intercept is 0, negative 2. And I have what I need to graph my line. First, start by plotting the y-intercept, 0, negative 2. Use your slope. Keep in mind your slope is positive, so my line will be rising. And you go up 2 over 1, 2, 3. Up 2 over 1, 2, 3. I can also go down 2 and run in a negative direction too. And there is my line. So for this one, keep in mind, if it's not already, the equation given is not in slope-intercept form, you have to solve for y first. Okay, for number 3, I'm going to give you a line, and I want you to give me the equation of the line. That is y equals mx plus b. We need to be able to, 1, get the slope, and 2, get the y-intercept. This one is nice and easy because the y-intercept is a pretty point. It crosses nice. So the y-intercept here is 0, negative 2. To get the slope, pick 2 good points, and the line is rising, so we're going up 1 over 2. And you notice that slope, we go up 1 over 2, up 1 over 2, up 1 over 2. So now I have all the pieces I need to write the equation. The equation of this line would be y equals 1/2 x minus 2. Okay, this next one, I'm asking you to get the equation line again, and we need y equals mx plus b. But if you look at this, we have the slope we can pick easily. The line is falling, so the slope needs to be negative. So we have 2 good points here. We're going down 1 over a positive 3, so my slope is negative 1/3. But look at my y-intercept. It does not cross nicely. So I cannot just guess or estimate. I actually need to calculate what the y-intercept is. So you may use the y equals mx plus b, or there's another formula called point slope. That you may use to get the y-intercept. We already know what the slope is, and we're going to use a point from the graph. I am going to use -1, 2. You could use any point, and you will get the same answer. And I'm going to plug these into the point slope formula. Y stays -2 equals -1/3. The x stays there. This has a minus, but I'm plugging in a -1. So minus a negative is +1. Now I will need to distribute the -1/3 through. That's -1/3 x minus 1/3. And then I'm going to add 2. Okay, you have a calculator, or you can do a little math. You have -1/3 plus 2 over 1. We need to get a common denominator of 3. So if I'm changing the denominator to 3, I have to multiply the top also by 3, which gives me a 6. And then when you add fractions, the 3 stays on the bottom. -1 plus 6 is 5. So you now have the equation of the line, and we used a point from the graph and slope. And notice the y-intercept is 5/3. That would be a very hard guess to make looking at your graph. So once again, this is maybe new, but the point slope formula allows us to find the y-intercept just giving a point in the slope. The next couple of slides deal with horizontal and vertical lines. As you can tell, when you look at this equation, x equals -4, it does not look like y equals mx plus b. There is not a y in this equation. I'm sure most of you have heard VUX. The V stands for vertical. Means it's a vertical line. The U stands for undefined slope. The X is that vertical lines will always have the equation x equals. So we go to where x is equal to -4, 1, 2, 3, 4, and we'll have a vertical line at x equals -4. The next slide, we have y equals 3. I'm sure you've heard of HOI. H stands for a horizontal line. The O stands for 0 slope. So the slope equals 0. There's no incline or decline there. And then the Y is the equation for all horizontal lines will be y equals. So you go to where y equals 3 on your graph, and you have a horizontal line. So as you can see, vertical and horizontal lines are different because they're not necessarily having a slope where you're rising and where you have a rise and a run. Okay. Now, going backwards, when asked to give the equation of a line that is vertical or horizontal, you have to kind of remember your little saying, HOI. It's a horizontal line, so it's going to be y equals, and go to your graph. Anywhere on this line, y is going to equal -1. Same for the vertical line. Remember Bucks. So this equation is going to be x equal, and you go out to your graph, x is -3 here. So at any point on this graph, x is going to be -3. So for example, if you were to list ordered pairs, we would have -3, 0, -3, 2, -3, -1. Anything in the x column will be -3. So the equation of this graph is x equals -3. The last two equations are just, we're going to talk about domain and range of a graph that does not look continuous. And we're going to talk about what the open circle versus a closed circle means. So if we're looking at the domain, remember we read the graph left to right. That open circle right there means when you read this graph left to right, that x value of -1 does not count. But notice this graph continues in the right direction, continuous. So in interval notation, that would be open bracket -1, telling the person that it cannot equal -1, but it continues on to positive infinity. In set notation, x would be greater than -1. Notice I do not underline that. The last one, we're going to talk about domain here, where we read the graph left to right, but now we have a closed circle. So in interval notation, you are reading left to right. It can be -infinity all the way to 0, and the circle is filled in now, meaning we're going to use a bracket because the x value of 0 does work. In set notation, it would be x values that are less than or equal to 0.